Great. Hi, everyone. I'm Saadia Gabriel, and I'm very excited to be here today to talk about some of the work that my research group at UCLA has been doing around simulating emergent LLM social behaviors in multi-agent systems. So I'll start with a quick introduction to my research group, which is the Misinformation, AI, and Responsible Society Lab. These are my 4 PhD students, Salman, Ashima, Sharif, and Ganglin, who've been doing some work recently looking at the role that large language models can play in spread and mitigation of misinformation, and the way that they can lead to these broader societal consequences because of their influence on information dynamics over social media. So I'm going to give a quick introduction to what large language models are. If you've heard of ChatGPT before, please raise your hand. Okay, almost a lot of people in this room. Have you used it before? Raise your hand. Also a lot of people in this room. So the model behind ChatGPT is a large language model. What these are these strong computational models that define a probability distribution over natural language. So we can perform many different tasks with these models, including tasks that weren't originally seen during the training for those models. Some examples of these tasks that have emerged out of this race amongst a number of different tech companies like OpenAI and Anthropic, Google, Meta, to develop stronger and stronger and more capable models, include creative text generation, as well as even drug discovery. There's been some work looking into use of large language models in this domain as well. And therapy chatbots, there are a number of existing applications where millions of users can freely download this and then interact with chatbots as a form of psychotherapy. So our particular interest in this research group is looking at how these large language models can actually influence information dynamics, which is increasingly problematic given the importance of online interactions for the spread of information and the way that that can have broader societal consequences. A lot of people's preferred medium for communication now is over social media, and this can lead to the spread of narratives that can have a real-world impact beyond these digital spaces, referred to by Nobel Prize-winning economist Robert Shiller as the contagion of narratives. We've seen some positive social effects emerge from the spread of these narratives, like greater informational accessibility, for example, access to medical information, but there are also negative social effects that have emerged from this, like spread of misinformation, in particular due to information overload, where the sheer quantity of information being spread online makes it harder and harder for people to discern truth from fiction. This is highlighted by this figure here, where we can see that the quality of the information being shared is not actually positively correlated with the information sharing behavior. And this can lead to some alarming phenomena, like what was uncovered by a Pew Research poll a few years ago during the COVID-19 pandemic, where they found that a quarter of surveyed Americans believed it was probable that the COVID-19 outbreak was planned by people in power. So I'm going to delve into some of the ramifications of this, in particular for influence operations. So these are large-scale operations that can happen online where there are specific coordinated groups of people who are internet manipulators, and they're trying to spread certain narratives. And they might use bots as part of this operation. This is something that had some significant news coverage a few years ago in 2016, where it was uncovered that there were operations centered in Russia that were actually trying to infiltrate legitimate U.S. social movements like the Black Lives Matter movement and imitate members of that movement, and then have some influence over the US political environment. And you can see here, this is a Twitter retweet graph from 2016 that's showing discourse around the Black Lives Matter movement. We can see that these internet manipulators were actually involved in both sides of the political discourse during this time period. So in the orange, you can see the accounts that were actually belonging to these agents who were coordinating this influence operation. So this was back in 2016, which was pre the era we're in now with these large language models, where we're seeing this behavior. But now we have this concern of how can large language models actually exacerbate this problem or provide new tools for internet manipulators to influence online discourse, due to the fact that with these large language models, we can now generate content at a scale that was previously unseen. And there's a lot of control that these human users can have over the type of content that's generated by the language models, so they can specifically embed messages or agendas that they might have into the generations and then spread that at scale through these social media networks. And some recent works have highlighted the persuasive capabilities of language models that might pose risks in this kind of scenario. This is one report from one of the developers of these large language models, a model called Claude. This is from Anthropic, and it was a blog post that was written by a number of people at Anthropic. It was led by Essen Dermos, where they were looking into how different variations, generations of this model can have persuasive capabilities and influence users around specific policy topics. And they were finding that actually there is a scaling effect where over time this model has become better and better at actually persuading people, and it is capable of changing people's opinions around policy. There was another recent work, this was from last year, it was published in Nature, that was showing that one of these large language models, GPT-3, can actually be used to generate personalized ads that are more convincing at getting people to spend money on products. So the personalized ads that were generated by the large language model actually led to people saying that they would spend more money on certain products. So this is particularly concerning when we think about the fact that there's evidence that people are being persuaded by these large language models, and there may be cases where people don't actually have the skills to discern if the arguments they're being presented with that were generated by these models are reliable or not. One thing that came up last year is that this is not just a risk. This is something that's actually happened already. So OpenAI released this report where they were saying that they did uncover a couple of cases of malicious accounts that were using their large language models and their platform to actually generate content for influence operations. They said they disrupted 5 covert influence operations. They managed to disrupt this before it reached critical mass, so it was at a smaller scale still. But what they found was that there were operations like this one that they called Doppelganger that was originating in Russia, where they were using these large language models to generate multilingual comments and then spreading those on social media platforms like X. So even though this hasn't reached the scale of being so problematic that it might actually affect geopolitical situations, we know it has already been deployed. So how do we prevent this kind of deception from large language models? That's the work that my research group is focusing on, where we have a few different projects around detecting false language, both from humans and from language models, as well as model auditing. So one of the directions that I'll talk about is trying to come up with interventions that are scalable against misinformation. Also looking into how can we have oversight of the persuasiveness of large language models, so we know if there's ethical concerns around persuasiveness and the potential for misuse of these models in specific scenarios. And how do we evaluate if these interventions are robust to domain shift so that they work not just with the examples that they were evaluated against during development, but also considering the way that the evaluation might need to change to reflect real-world environments that they would be deployed in. And how do we model intent and consequences, looking into forecasting and coming up with sophisticated evaluations that will allow us to assess risks into the future. In particular, I'm going to highlight some work led by my PhD students, Ganglin and Solomon, that are looking into developing evaluation environments for, in particular, trying to identify risks of negative persuasion. So these evaluations touch on this concept of scalable oversight, which I'll quickly go over with this classical example where you could think of there's somebody who needs a fast sorting algorithm, and they go and ask a language model to generate code for this sorting algorithm, but they themselves don't have any prior knowledge of coding, so they have no way of evaluating if the solution they've been presented with is actually an accurate solution or not. And so this is a scenario we're facing now where we might not have experts who are actually able to assess if the arguments presented by these language models are accurate or not, and we need some way of being able to tell just with lay people who don't have domain expertise. The first work that I'm going to get into was the motivation for the work of my PhD students. This was a project that got started during my postdoc at MIT, where we were really interested in this question of whether language models themselves could be used as interventions against misinformation. And so in this work, we decided to see if we could use language models to generate explanations that would help lay people with determining if arguments were reliable or not. One of the motivations behind this work is that the very nature of social media platforms can encourage the spread of misinformation. We have these environments where people tend to cluster in groups of others with similar interests. This is a phenomenon known in the social sciences as homophily, and that's actually encouraged by the recommendation algorithms underlying these platforms themselves, where people get exposed to content that reinforces their existing preferences and their existing beliefs, and may never be actually exposed to content that might refute false beliefs that they hold. So the idea here with these interventions is we want to find a way of generating scalable explanations that could expose people who are otherwise blocked from useful information in their information validation process to factual knowledge that can help them in their online literacy and their ability to discern between the truth and false content. And there's a lot of prior work, particularly in political science, that has highlighted how this kind of approach can help in improving discernment of users. So there is this idea that misinformation sharing often comes from people having an incomplete knowledge model, and then if we can expose them the facts, then we can improve their discernment. And this work is shown to work both for humans and for language models. There's been this area that's opened up in the field of computer science, and particular natural language processing, of retrieval augmented generation, where we can actually improve the ability of language models to reason by integrating facts into the inputs, retrieved facts into the inputs for these models, and that's shown improvement in factual accuracy in tasks like generative question answering. And so just to quickly go over what we did is that we use language models to generate these explanations, and we conditioned this generation process on attributes of the users, so we could come up with personalized explanations that might help in cases where we have users who are more vulnerable to misinformation. To test this, we set up a controlled simulation environment of a news feed on a social media platform, which I'll show here with this video. We did a survey first to get demographic information about users that could be used in the explanation personalization. And then we showed them the simulated feed that looks exactly like a social media news feed. They can like, share, and flag content, and they can also interact with these language model generated explanations and then rate what they think the reliability of the news is. And so we did a randomized controlled trial where we first showed them the news without any kind of intervention, and we can see that this is a very difficult task for lay people. And then we showed them 5 different kinds of interventions. I can go into detail at the end about each of these types, but for time, I'll just quickly go through this, where GPT-4 is the explanations from this work, and we can see that after exposure to these interventions, their accuracy at determining if it's misinformation or real news improves significantly, but particular for explanation-based interventions. One problem that we uncovered, though, is that it's not always true that the explanations themselves are accurate, even though they're arguing for the real label of this being misinformation or real news. There are some cases of erroneous reasoning in these explanations where the language models are actually arguing for the right answer in the wrong way. So this leads to this risk of then actually trying to counter misinformation with misinformation. And so in the next part, I'll briefly talk about how do we actually evaluate LLM persuasive capabilities in both the positive use cases of what we had before trying to detect misinformation, and negative use cases where they might accidentally or on purpose be trying to persuade people to believe in misinformation. And this is work with my PhD students and a number of wonderful external collaborators. So one approach we took was a debate approach where we define this zero-sum game where we have 2 different LLM agents that are assigned to opposing sides of an argument, and they can present statements that back up their argument or refute the other's argument, and then we have a judge who ultimately decides which of these agents has actually come up with the most convincing argument and won the debate. And so I'll start with talking about results from a simplified version of this. It was in consultancy, where we have a single agent trying to persuade a judge. Or experiments we ran with some examples of COVID-19, misinformation and true news claims, as well as looking at climate change, misinformation and real news. And we first looked at the baseline accuracy of these language model judges. So we have a GPT-4o judge and a Quinn judge, and we can see that, particularly for GPT-4o, it's actually getting pretty reasonable accuracy at discerning between misinformation and real news. But we see this competency drop significantly after exposure to arguments from the agent arguing for the incorrect answer. So what we actually see is that these results are not stable. We have either a significant increase in accuracy in the correct persuasion case or a significant drop in the incorrect persuasion case. And this is true across domains, not just for COVID, but also for the climate news claims. When we do the debate comparison where we have the two different agents arguing for opposing sides, then we actually see the incorrect persuasion winning out, which is really concerning, particularly given the interest, both in our previous work and in others' work, around the use of language models for this kind of positive persuasion. So this just emphasizes the need for these two-sided evaluations that are actually taking into account the risks of negative persuasion. So another approach we looked into for actually being able to measure risks from persuasion of large language models is looking at simulations of full social network interactions. And this was inspired by a number of prior works, including work like NetLogo that looked into, several decades ago, into agent-based simulations for understanding emergent phenomena, as well as more recent work specifically looking at social simulations with large language models, for example, some work at Stanford and work at CMU. But while this previous work with language model-based social simulations was focused on in-person interactions, we were really interested in social media interactions where we have these environments that there might be direct interaction between human users and language models. And so what we did is we used language model agents to personify diverse users, and we connect them within this social network graph where they can interact with each other, for example, refuting information or supporting information that they're being exposed to, but also sharing information amongst themselves and liking information. And so there's a few different use cases for this, one being just being able to model user representations themselves and see how we can develop the most accurate and faithful representations of actual users. We can also look into modeling population-level behaviors like the possibility of flash crashes happening from information spread. We can look into content diffusion predictions, so looking at how popularity metrics of different types of content. And we can also look into the effectiveness of different kinds of misinformation interventions, which was our particular interest. So really quickly going over some of the details of this, we have this directed graph where we have these user nodes defined by these agents. We also have relationships defined between these nodes where there are different users following each other. We spread content within the simulated environment from different news sources. In particular, we had a partnership with a journalistic organization called NewsGuard, where we got access to their reliability labels, as well as specific misinformation narratives that are commonly being spread right now. And we verified the realisticness of the simulation by looking at specific network patterns that are common, well known already in actual human social networks, like homophily, where we see users connecting because of similarities, power law distribution, where we see that there are specific influence patterns that emerge where some users are going to have more followers and be influencers within these social networks, and triad closure, which is this phenomena where we see that friends of friends are more likely to then become friends themselves. And so these are some examples of these simulated agent interactions that you can see, as well as some information about how we're instantiating these agents. So we have these very detailed profiles. This is showing flagging patterns of news content over time in the simulation, where we're seeing more flagging of the false news, some examples of flagging of the real news. We can also look into liking and sharing patterns emerge. And then we have this replication of actual content moderation systems. like community notes, which was originally piloted by X and has now become more widespread. Meta is using this kind of content moderation as well, which hands it over to the users to actually identify cases of misleading content and provide some context for why this might be true or false. And so here we see a visualization of this simulated network where you can see all the different agents and their following relationships. So some interesting observations we have from this is we do see the emergence of these influencers like we would expect. That mirrors real-world social media dynamics and not exactly aligning with what we know from the social sciences. But this is closer than we've seen before. And we see some early examples of homophily as well. And we actually ran a human study comparing between human users and their matching agents and using snapshots of the same content from this simulation. And we see no statistical significance in terms of a number of engagement patterns, like liking content. So there'll be a preprint coming out of this soon. I think in the next 2 weeks, we're aiming to have this out that will go into detail about everything that we did and the results, including comparison of different content moderation strategies within this simulation and some recommendations for development of future online governance. Just to end this, I want to highlight that one of the main advantages of this compared to some alternatives in the past, like piggyback prototyping, where you try to build these studies on existing social media platforms, is one, with the type of data that we're working with, this misinformation, there can be a lot of ethical concerns that come up in those studies. And if we can work with these agents, then we don't actually have to expose real human study participants to this content. And this is also more scalable, so we can run these simulations without having to worry about human participant recruitment for this prototyping process. So some of the ongoing challenges that we want to investigate with these kind of evaluations is how do we come up with more effective content moderation, in particular content moderation that is culturally sensitive, especially given that there's been prior work showing that wisdom of the crowd can sometimes be discriminatory when we're relying on majority opinion, and that can actually overlook a lot of cultural variation, which can lead to erasure of minority users' speech and other types of discriminatory behavior. So that's our ongoing work, is to actually look at how we integrate value pluralism and into content moderation to accommodate some of the variation we see, like examples of reclaimed language use within communities or examples of self-narratives. So I can talk more about that and the work we've been doing with the UCLA initiatives to study hate after this, but I think I'm out of time. So I will end there, and please let me know if you have any questions. Feel free to email me, or if you want to collaborate.